Do you want to learn how you can create an API to add data to your existing DynamoDB table? In this video, that is exactly what we're going to learn how to do. Hi guys, I'm Sam with Complete Coding, and in this video, we're going to be learning how we can create an API endpoint that can not only get data, but can put data onto our DynamoDB table. So we're going to jump into the code right now and see what we need to complete that. To create our create player score endpoint, there are three things that we need to do. The first is creating a new API code inside endpoints. The second is taking our dynamo.js file and extending it. At the moment, it can do getting from Dynamo, but we also want to write to Dynamo. So we need to make those changes in that file. The last thing we need to do is go into our serverless.yaml file and update the configuration to allow us to deploy that new API endpoint. So to start, we're going to be creating that new file in endpoint.js. So create a new file called createPlayerScore.js. And in here, we're going to be creating the new endpoint. This endpoint is going to actually look relatively similar to the getPlayerScore endpoint. So what we're going to do is open up the getPlayerScore endpoint, select all of the code and copy it. Back in our createPlayerScore code, we're going to paste it in. This is a good boilerplate for how our endpoint is going to work. We have a table name from the environment variables. If there isn't an ID on the path parameters, we're going to say that we need an ID. And then we're going to get the ID from the path parameters. Here, we are getting the data from a table name. So this is where the code is going to change. So we're going to delete these lines and add in some new lines. So the first thing we need to do is we need to get the body from the event. When API Gateway passes the body through to a Lambda, it stringifies the body. So we need to use JSON parse to get it out. So const user equals json.parse, and we're parsing event.body. Now we have the user. We need to make sure that the user has the same ID. We can do that by simply writing user.id equals ID, which will input that ID onto the user object. Now we need to write it to Dynamo. So we're going to write some code, assuming that we're going to add the code to our Dynamo.js file. So we're going to define a new const new user equals an awaited dynamo.write, and we're going to pass up the user and the table. So pass up the user and table name. If this fails, we need to catch it. So add a .catch, where we take the error and we console log that there was an error. Error in Dynamo write, and put the error into there. As well as that, we need to return null. So return null and save that. So now that we've got the new user back from a successful Dynamo write, or if there's an error, new user will be null, we need to check that new user exists. And then if it doesn't, we send a message saying we failed to write the user. by ID. So that is the new message that will come back if there's a failed Dynamo write. And if we are successful, then instead of returning the user, we're going to return a new user. So that is all of the code inside this file. So we can move on to our dynamo.js file. Inside this file, we only have a get function at the moment. So we're going to add a new write function. This is going to be an async function. And this is going to take two parameters, which is some data and the table name to where we're going to write that data. Inside this file, we need to check that the data has an ID. That's because all of our tables need to have an ID as their unique parameter, and if it doesn't, Dynamo will fall over, and we don't want to have errors because of that. We then need to create the parameters and create the request to Dynamo document client. So the first thing we need to do is check if data has an ID. So if not data.id, we can throw an error of no ID on the data. If there is an ID, then we need to create the parameters. So const params is an object with table name and a item. This is the item that we're going to be writing to the table. So we're going to pass in the data that we have received. After this, we need to create the request to the document client to put the data onto the table. So const res equals await document client dot put, and we can pass in the params. So that's the parameters passed in. And the last thing we need to do is add dot promise on the end, which makes sure that this is an asynchronous promise and not using callbacks. Inside this, we now need to check that the response is valid and is not null. So if there is not a response, we need to throw an error. And this time I'm going to use template strings to allow us to dynamically insert data and say there was an error inserting ID of data.id into table name. So that's a very descriptive error message which tells us exactly what data and what table we were trying to write to. If everything is successful, then we can return the data that we were trying to write into the table. And if we save this, we now have the data returned, which becomes the new user and is then returned to the person who made the call to our API. The last step to do is adding the code to our serverless to configure the API. In the last video, we created this IAM role statements, which gives DynamoDB permissions to all of our lambdas. That means we don't need to add anything else for this lambda. As well as that, we also have the environment variables of table name, which is set to the custom table name value, which is just here. So we'll always be writing to the player points table. As all of that is set up, the only thing we need to do is add a new function here. This function is going to be the create player score function. It's going to have a handler of lambdas / endpoints slash create player score dot handler. As well as that, it's going to have events, just as the previous endpoint does. Again, it's HTTP. It's going to have a path on it of create dash player dash score slash ID. Now, here is where it's slightly different to the previous API endpoint. The method for this one is a post request. This is because you need to use a post or a put request to pass data up to an API endpoint. A GET request only can pass up data inside the path, such as something like an ID. As we're passing up more, it's going to be a post request. We'll also add on clause and save this file. That is everything created. So what we're going to do now is run SLS deploy and see if our API endpoint is deployed. As you know, this takes a little bit of time, so I'll get back to you when that is done. Now that has finished building, we can scroll up and see that we have created a new function called create player score and a new endpoint, which is a post endpoint of create player score. So to test this, we can't just go into a web browser like we did with the GET request. So we're going to open up an application such as Postman. First, copy this URL and then go into our API Amazon console. If we go into DynamoDB, into our tables and our player points, we can see from the last episode that we had one user in this row. If we now want to add a new user using our endpoint, we can open up an application such as Postman. This allows us to make more requests than just a GET request, as you can see here. So we're going to be setting this to a post request and pasting in our URL. We need to add an ID to the end of this. So 123890. This needs to be different to the ID of any existing rows. And then we also need to add a body. In Postman, you do this by selecting raw and JSON. It's an object, and then we have to add our fields. So this one's going to have a name of Sarah and a score of, let's say, 15. If we now send this request, we can see that we get a response of new user with the data that we have just posted up. If we now move back over to our table and refresh it, we can now see that this new user, Sarah, with a score of 15 has been added to our table. We could then use our GET API to get this data back if we wanted to. In this video, we have now created our API endpoint where we can write to our DynamoDB table. This is great as we can now hit that and post up data from our front ends for any application that we need to. If you've made it this far into the video, then you've probably learned something new. So please make sure to hit that like button because it really helps out the channel and helps YouTube suggest it to more developers just like yourself. If you want to find out more about YouTube and serverless, then make sure to hit the subscribe button to follow me and get updates every time I release a new serverless video. Thank you, and I'll see you again next time.